actual coding. Okay, so we will start with our first algorithm, that is trees. Okay, so let me quickly share with you the presentation. So the presentation will be little bit dry, so but it is very important. The reason is, unless and until you know how the algorithm works at the back end, it is very difficult to understand the coding part, that is a process of coding. So without logic and without the knowledge of the algorithm, it is very difficult to code that particular algorithm. So with this short note, we will start with our first algorithm, that is decision trees. In short, it is also known as trees algorithm. Okay, so decision trees is the complete name. In short, it is also known as trees algorithm. Okay, so imagine that we have some sample data. It's a just sample data. It has around 13 columns. If we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 columns, and 1, 2, 3, 4, 5, 6, sorry, 13 rows and 6 columns. So the data set consists of 13 rows or 13 observations and 6 columns. So if we look at the columns, we have the column names as ID, age, income, family, CC average, that is credit card average, and personal loan. So these are some of the columns that we have, and in each column we have something like, if you go for age, we have young, middle, old. These are called classes, levels, or categories. Okay. Income, if we go, we have low, medium, high. There are three more categories, levels, or classes in income. Family, we have one, two, three, four levels, classes, or categories are four. Similarly, when we go for credit card average, we have low, medium, high, three. And in personal loan, we have only two categories, that is 0 and 1. 0, okay, represents no, and 1 represents yes. Okay, students. So in this data, and if we go for ID column, we have around 13, okay, categories. The main reason being, the same ID cannot be given for more than one row. Okay, that is the reason we have only 13 records, and 13 records have 13 unique IDs or categories. Okay, students. Now this is about the categorization of the columns. Coming to the columns, segregation of the columns, right from ID to CC average. That is ID, age, income, family, CC average. They are the independent attributes. And personal loan is the dependent attribute. So we have 5 independent attributes and 1 dependent attribute. Okay. So this is how the data is spread. Okay. Now let us see how a tree is formed. So it requires little bit of attention. So please concentrate. So let us go to the next slide. So constructing a tree. Suppose we are not concerned about the dependent attribute, that is personal loan. We will only start with from ID, age, income, family, and credit card average. We choose one column. Okay, so how we choose the column and all, I will explain you in some time. But imagine that we have applied some formula. Based on that formula, we have selected CC average as the column, that is starting point of the tree. Okay, So CC average is the starting point of the tree. It has total 13 records. If you go to the number of records, we have total 13 records. And how these 13 records are classified, look into the personal loan column. Okay, look into the personal loan column. The personal loan column has 13 records. Out of that, the first 6 records are 0, that is no, and the last 7 records are yes, that is 1. So these 13 records are classified into 6 no and 7 yes records. Okay, that is the how the CC average total column is built. Now coming to the second part of the tree. Okay, so this is the second part of the tree. What we have is, okay, how CC average is divided into. So CC average is divided into three categories: low, medium, high. That is what we have written. So CC average is divided into low, medium, high. Then let us go and look into the each category. So number of records which are coming under the low category: 1, 2, 3, 4, 5, 6, and the last two total 8, 7, 8. So there are 8 records of low category, out of which the first 6 records are of class 0, that is no, and the last 2 records are of class 1, that is yes. So in low we have 8 records, out of which 6 are no and 2 are yes. Coming to medium, there are 3 records which come under the medium category, and all the ones are of class or category 1. So medium has 3 records and all are yes. Coming to high, we have 2 records of high, and both of them are of class 1. So 2 records are of high and all are of class 1, means yes. So here what we should understand is, if we have a certain number of records and all these records are of same class, whether yes or no. Okay, here it has come yes, but it might be no also. So when we have certain number of records and all the records are of a single class, that part is called leaf. Okay, that part where we have n number of records, all that records are of either yes or no class or category, that stage is called leaf. So when we look at a tree, we have the starting part as the root, followed by branches, followed by leaf, and leaves are the last part. So above leaves, we don't have anything. So here, the starting point where we have started is called the root, and from root to this part leaf is called a branch, and where we have certain number of records and all the records are of same class, it is called the leaf, and there is no need for us to go further. So in medium we have records 3 and all are of yes. In high we have 2 records and all are of yes. So there is no need for us to split further. But coming to the class low, we have 8 records, 6 are of no, 2 are of yes. So this is not a leaf. So there is a need for us that we should go further. So CC average is done. What we are left with is ID, age, income, family. Out of these 4, we will choose one more, okay, attribute here or column here, and we will proceed with that column. So wherever we have a leaf, we will stop. If it is not a leaf, we will proceed further. That is how a tree is constructed. Okay, students. So let me quickly recap. See, constructing a tree. The starting part of a tree is called a root node. From tree, we start splitting, and at a stage we reach where there are certain number of records and all the records are of a single class, whether yes or no. That stage is called a leaf. So from root node to leaf, it is called a branch. So we have three, okay, we have one root node and two leaves. Okay, so we have two branches here. So how did we split? We have five independent columns. So we chose CC average. Let us say we have applied a mathematical formula. Based on the formula, we have identified that credit card average works better. So we have chosen that CC average. So CC average column has 13 records. Those 13 records, how they are classified as a total column, go and look into the dependent variable column, that is personal loan. So out of the 13 records, 6 records are of class 0, 7 records are of class 1. That is the reason we have put CC average has 13 records, 6 no, 7 yes. Now how the CC average column is divided into? It is divided into three categories: low, medium, high. If we look at the low category, we have 8 records. Those 8 records are classified into 6 records are of class 0, that is no, and 2 records are of class 1, that is yes, that is 1. So this is how we have written total 8 records, 6 records of no, and 2 records of yes. Coming to medium, we have 1, 2, 3 records, and all the 3 records are of class 1, that is yes. So we have written here records are 3 and all are of a single class yes. So this is the leaf node. There is no need to split further. We are done with it. Coming to the category high, we have 2 records, and those 2 records are of class 1, that is yes. So again, there is no need for us to split further because this is a leaf node. So from root node to leaf is one branch. The second branch is from root node to the second leaf. So we have two branches. Low is not a branch because we have 8 records and they are not, all the 8 are of not a single class. They are of two classes, yes and no. So we don't call it a leaf node. So what is the next thing that we are supposed to do is, from the remaining independent attributes variables columns, we have to choose one more column, that is apart from CC average, we have ID, age, income, family size. Out of this we will choose one column and we will split further. This is how we construct a tree. Okay, so let me go through one another example so that you will understand. Let us imagine that family is chosen as the root node. Family again has 13 records. So when we start with any root node, we have the same number of records, that is 13, out of which 6 are no, 7 are yes. Coming to the family column, we have 1, 2, 3, 4. Okay, we have 4 categories. That is the reason we have jotted down. This is the first category, second category, okay, third category, and fourth category. Coming to the first category, how are they classified? So first category has 1, 2, 3, 4 records. The first record is of class 0, second record is of class 0, third record is of class 1, fourth record is of class 1. So we have 4 records, 2 are no and 2 are yes. Okay, so this is not a leaf node. Coming to family, okay, category 2, we have a single record that is of class 1. So we have a single record that is of class 1. So this can be treated as a root node. Coming to family, and the category is 3. So we have record 1, record 2. One record is of class 0, the second record is of class 1. That is the reason we have written there are two records, one is no, one is yes. Again, this is a root node. And the last one is 4. Okay, category 4, we have 1, 2, 3, 4, 5, 6 records. The first one is 0, second, third are 0. The remaining 3 are 1. So there are 6 records in category 4. 3 are no and 3 are yes. So students, one more thing, remember that here for sample I have taken, if we have 6 records, 3 no, 3 yes. If we have 4 records, 2 no, 2 yes. It is not always. It can be, suppose 6 records we have, it can be 2 records of yes and the remaining 4 might be of no. Okay, or it might be 5 records of yes and 1 no, or 5 yes, 5 no and 1 yes. So it might be of any combination, because this is a dummy data I have taken like that. Okay, so coming to the first say category, it is not a leaf, so we cannot stop here, we need to continue. Second one, again it is a leaf, so we can stop here. The third one is not a leaf because we have two records, one yes, one no. We cannot stop here, we have to proceed further. Again, there are 6 records which are, okay, divided into 3 no and 3 yes. We can split further. So let us take the first example. So family is used, what are remaining is id, age, income, cc, average. Out of that, again I have applied the mathematical formula. Let us say age has come, so I am taking age as the next splitting criteria. So how we should split is, go to age and look the number of categories. We have young, middle, old. Okay, that is how we have categorized. So when we have family is equal to one category, and age has three levels, that is young, middle, and old. Now, how these records of, okay, category young in age are divided into? So don't look into the young category. What we are supposed to look into is family is equal to 1. Then in that we have to look into age. So family is equal to 1 has 4 records. So family is equal to 1. It is not young, it is middle, leave it. Family is equal to 1, let us say the second record. So again it is not young, it is middle. Let us look into the third record. Family is equal to 1, it is middle. And the fourth one, family is equal to 1, again in age it is middle. So family is equal to 1, there is no record which is coming under the category young. That is the reason we have recorded as no records. Similarly, when we say, okay, family is equal to 1 and age is equal to old, there are no records. So we have jotted down no records. Then coming to middle category, we have seen that we have 4 records. Again, they are divided into 2 no and 2 yes. So this is not a leaf. Again, we have to proceed further. So from the independent attributes, family is being utilized, age is utilized. We are left with ID, income, and CC, average. Now again, we can choose one more attribute here, and we can divide it and we can move further till all the records are of leaf category, or there are no records at all. Till that stage we need to go further. Okay, this is how a tree is built. So any doubts? If you have any doubts, please put it in the chat box so that I can know at what stage you are. Can anyone put it in the chat box whether yes? It is like decision trees and random forest. Okay, it is not like it is decision tree. Okay, so we are talking about decision tree itself. It is not like. Okay, so did you understand how a decision tree is formed? See, you can get a ready-made code from the net and all, but you will not get these details how these trees are formed. Okay, that is the reason I am trying to take some time and I am trying to explain. So Vishnu Teja is asking, for one we take next attribute as age, for 3 4 also we take only age. No, there is no rule that you should take age. Okay, so again you apply some formula, it might come age or it might come some other thing. So even if you take age also, Teja, it is not okay guaranteed that you will get the same output. Why? Because let us say family is equal to 3. So let us look at that. Family is equal to 3 has only two records. What is that? Family is equal to 3 under age we have old, and family is equal to 3 we have old. So there are no records in the other two categories. Suppose if we get age also under family is equal to 3, we have only okay data under old, so we don't have records under young and middle. Okay, so that is the reason again. Okay, here y and m categories of age will have no records, and age will have only records of 0. Okay, that is not 0, old. O. Coming to the category 6, so we have 6 records in category 4. The first one is young, second, third are middle, then young, middle. So there is no old here. We have records which are of 4 middle and 2 young. Okay. So again there are no records of old. So this is how the data is spread. Okay. So there is no need for us to think much, because the tree okay algorithm works in the similar way. So even if we get the same attribute, there is no need for us to think that the data might be same, because in the first one we have only records which are coming into middle. In the third category of family we have only two records which come under young, no old. And in category 4 we have 6 records, out of which 4 come under middle and 2 records come under young. So there are no records under old. So the data is different. So even if you split further, another attribute might come, because family is done, age is done. So we are left with id, income, and say CC average. It might choose one more attribute, it will split. That is how it works. So at some point you will achieve the stage of leaf. Okay. But again, achieving a stage of leaf is a very dangerous condition. Why? I will try to explain you when we move further. Okay. So if we have, see, the condition is we have medium in CC average, there are records 3, all are of yes. In high category we have records 2 and all are of yes. So there are two branches. So how can you write each branch? You write as, if CC average is medium, then loan is equal to yes, because this independent attribute is personal loan. So the first rule or branch what you say is, if CC average is equal to medium, then personal loan is equal to yes. The second rule says, if CC average is equal to high or is high, then loan is yes, because medium and high are of yes. So when you have your right hand side as yes, we can combine the left hand side. So left hand side, what you can write is, if CC average is medium or CC average is high, then loan is equal to S. So if a person is having credit card spending average as medium or credit card spending is high, then that individual will get a loan. This is what this rule is saying. Okay, so seldom we will give loan on a single attribute, but as this is an example, I am just quoting. So when your right hand side is same, that is loan is equal to S, you can combine your left hand side with R. So what do I mean is, branches are connected. Medium is high is one branch, and medium is okay, sorry, CC average is medium is one branch, CC average is high is second branch. So when your leaf is of same category, then you can combine these branches with the help of OR. Okay, if CC average is medium or it is high, then loan is yes. This is how it works. Now, decision tree is one of the most sought after, okay, algorithm in machine learning. So why do we think that it is most widely used, or people prefer, or data scientists prefer, okay, this particular decision tree algorithm? So there are quite a few, okay, advantages. The first one is fast and robust. So why are we saying it as this particular algorithm is fast and robust? The main reason being that is, when you build a model, there is something called learning. Okay, your train algorithm should learn and it should predict. So there is a learning and there is a say prediction. So there are some algorithms which are very good in learning. Okay, learning is also known as training. So if someone uses training, you don't, okay, panic what is this training. So learning and training is one and the same. So model is learning, our model is getting trained, that is what we say. So based on the good learning by the model or good training by the model, it predicts accurate outcomes. Okay, so where there are some algorithms which are very good in learning, but they are very poor in, okay, predicting. There are some other algorithms which are very slow in learning or training, and they are, but once they learn, they slowly learn, but they are very fast, accurate in predicting. Okay, so few are very good in learning or training, but they are very poor in predicting. Few are there which are very poor in learning or training, but they are very quick and fast in predicting. So, but decision tree algorithm is such, okay, algorithm, it takes decent amount of time, not too short, not too long. It is a decent amount of time in learning and also predicting. Okay, that is the reason we call it fast and robust. Second one, it requires very little experimentation. Suppose if we have outliers within the data, we have gone through the pre-processing phase in CRISP-DM process. We said that when we have some outliers, when we have some missing values, we have to remove them, else the model will not give the accurate result. But when we deal with decision tree, even if we have outliers within the data, it will handle those outliers. So when we are doing a project, I will show you, I will do some changes, but I will not remove the outliers. I will keep the model, okay, built with outliers data, and I will show you how good the accuracy will come. So it shows that how the decision tree learns even after having noise in the data. Noise is nothing but the outliers within the data. So decision tree requires very little experimentation. It can handle few things by itself. Again, it is a problem. How? I will explain you. Then you may also build some intuitions about your customer base. Means intuitions means rules. So decision tree is the only algorithm which will generate rules by itself. So what are these rules? Suppose let us say Maruti showroom is trying to come up by using this decision tree algorithm on some database it has collected. Then it says that people under 35 years of age, people who are earning above say 7 lakhs and below 10 lakhs, and people who say whose salary, okay, whose education is masters, and whose family is, okay, greater than 4, they will buy Brezza. So these are the rules. It tells about, okay, each and every independent attribute that is being used in the model building about that particular individual who is buying a particular model of a car. Or if a bank, so okay, if a bank applies, what type of people will take a loan? It says that people who are in between this age, working in, okay, with so and so experience, which education like this and this, they stay here, their savings is like this, their family size is like this, so on so forth, will take a loan. So these are called rules. So companies, organization love rules because if they have massive amounts of data, they can filter out the data and they can come with fewer records so that they can work on those records. Suppose if a bank has 10 lakh records, it can apply filters based on the previous data rules, and it will get, say, from 10 lakh it will filter out say 9.5 lakhs, and it will only have 50,000 records. Okay, and first they will start with that 50,000 records. That is how these intuitions or rules are formed by decision tree algorithm. And the fourth one is decision trees are taken, those decision trees are selected, taken, which are short in size. So recently, just before these advantages, I made a statement that the lengthier the trees are, it is a problematic case, it is not a good case. Why? Because, okay, trees may learn excessive more than required. That is the reason decision trees which are lengthier, which are too long, are not accepted. The ones which are short, which carry information, are selected. Okay, at the end decision tree, okay, some attributes are not selected, so we can leave them as unimportant. So what do we mean by that? Is when we are building a model with say 40 independent attributes, we start with 40 independent attributes, but the model will come up and say that 40 are not at all required. You build a model with only these 10 or 12 attributes, that is enough. So you don't spend much time on the remaining 28, okay, independent attributes, because they don't add value at all. Please use only these 12 independent attributes. So this is what the decision tree gives us. So these are the, okay, most beautiful advantages of using the decision tree. The first one is fast and robust. It is very quick in learning and also predicting. Requires little experimentation. Suppose you, okay, didn't take out say the outliers, but still it can work out. Okay, it will give rules, and the one which is short will be used most often. Then it will also tell us which attributes, okay, attributes means columns, which headings or which type of data should we use and which type of data we can throw away, we can leave it. So these are some of the advantages of decision tree. So decision tree are primarily used for classification rather than regression. Now we are learning a new term called regression and classification. What is that? Suppose India and Pakistan is playing a cricket match, and there are some analysts which they want to predict which team will win, whether it is India or Pakistan. So we have only two options, whether India or Pakistan. Say one is India, two is Pakistan. So when we have two options or we have three options and we have to choose any one, it is called a classification problem. Suppose it is cloudy, so whether it will rain or not. So there are only two options. It is called a classification problem. Suppose you are writing an exam. So whether you will pass or fail, or you are applying for a job, you will get a job or you will not get a job. So when we have certain number of options, okay, fixed finite number of options, that is called a classification problem. True, false, yes, no, 0, 1. Such cases are called a classification problem. Coming to the second category, that is regression. What do we mean by regression? When the output we are trying to come up with consists of numeric values. Example, suppose if we want to come up with a score, projected score, if we are matching, okay, if you are watching any cricket match, it shows that projected score. So how will they come up with the projected score? They use the algorithms. So when the outcome is a numeric value based on your historical and the current data, they will predict a numeric value. That problem is called a regression problem. Suppose you are applying for a loan. So you asked for say 1 crore, but the banker will not give you 1 crore. He might give you 80 lakhs, 85 lakhs, or 91 lakhs. So how does he arrive at that number? So he will not give you a random number, but they apply the algorithm based on your past performance and the data you submit. Based on that, they finalize that particular value. So they arrive using regression problem. Okay. So how much it will rain? How many marks will you get? Okay. So all these come under regression problem. So when coming back to our decision trees work very well with classification problems. But it is not that it will work only with classification, it will also work with regression. So predominantly, mainly it works with classification. Okay, beautifully it works with classification. With a minor change, it can also be used for regression type of problems. That is what I am saying. So regression trees are those trees where we can modify the existing decision tree and we can use for predicting a numeric attribute. Okay, that is a regression problem. So we have started with how a decision tree looks, okay, how a decision tree is constructed. Then we have seen at the advantages of decision tree, and also we have learned about classification and the second one is regression type of problems. These two come under predictive analytics. So predictive is divided into regression and classification problems. So we have seen the difference between regression and the classification problems with some examples. Okay. So we also made a statement that by slightly tuning the algorithm decision tree, it can also be used without any problem for solving regression problems where the output or outcome is a numeric value. So this is all about the first part of decision tree. The second part is lightly technical. So we have made a statement that we apply some mathematical formula. On that formula, we apply that formula on all the say existing independent columns, and whichever independent attribute has the highest value, that will be treated as the starting point of the tree. Okay, whether it is family or whether it is CC average, whatever it is, that is how we come up with one independent attribute. Similarly, on what basis we come up is, say, entropy. So randomness is nothing but error. So entropy is a measure of randomness. Measure means we are trying to calculate the noise, the error within the data. So whenever we talk about the error, error should be low. Okay, that is the reason if we apply entropy, the formula is H is equal to minus sigma pi log pi to the base 2. So this is a statistical formula, so don't panic about this. If at all you are not comfortable with it, please leave it, but keep a light knowledge of it, because tomorrow if someone asks you on what basis the data is splitted, so can you give me any one criteria? If you say entropy, if they may also ask you the formula. So the formula is minus sigma I pi log pi to the base 2. This is the formula of entropy. So entropy is error. So we will use this entropy formula on each and every attribute. Whichever attribute has the lowest entropy value, that will be treated as the root node. So lowest entropy value will be treated as the root node. But here comes a problem. So after few years, few statisticians were not happy. They were saying, why are we choosing an independent column which will act as a root node based on error? Error itself should be removed. So based on error, why are we identifying one root node? So can it not be modified? So they have come up with a new say concept, that is a statistician by name Quinlan has come up with a new concept. It is called information gain. So what he said is, let us calculate entropy at the beginning. See, this is at the beginning. We calculate, okay, entropy at the beginning. Let us call it as A. Then at the same time, we will calculate the entropy after splitting. Let us say this is after splitting. Let us call it B. So from A, if we split or if we subtract B, whatever we are left with, that is called information gain. So entropy at the beginning minus entropy after splitting, okay, whatever we are left with, the particular value, the amount, that is known as information gain. So and the statistician said, okay, it is good, so we will stick with the word information gain, and whichever attribute has the highest information gain, that we will choose as the root node. Okay, so entropy was lowest, but this information gain, we will apply this on each and every independent attribute. Whichever independent attribute has the highest information gain, that will be treated as the root node. Okay, so this is quite opposite of our entropy. So entropy initially, the attribute with the lowest, okay, entropy value used to be the root node. So I'm talking about only independent attributes, not okay adding dependent. So dependent should never be added. Then information gain. So entropy at the beginning minus entropy after splitting, whatever we are left with is called information gain. So the attribute with the highest information gain will act as the root node henceforth. This is what they said. Okay, but here comes a small problem. So whether we are applying entropy or say information gain. Again, after few months or years, I'm not sure. After a certain amount of time, again the statisticians identified that even information gain has an error. What is that error? So let me go back to our table. Suppose information gain is calculated for ID, age, income, family, and CC average separately. What they found out is regularly, say, information gain for ID is coming high when compared to age, income, family, CC average. Suppose if they are not adding the ID column, if they are left with only age, income, family, CC average, certain independent attributes, then any one attribute is coming on the top. Means that particular column has the highest this information gain. But when ID column is kept as a part of independent attributes, so invariably, compulsorily, ID column is getting the highest information gain value. So as per the rule, the attribute with the highest information gain should be the root node. But say employee ID or roll number, such things has no value because they are only they are used to represent only that particular row. Unless and until that row is present, it has some value. Apart from that, there is zero value for that ID or say roll number sort of values. So again they started to think why ID column is getting okay higher information gain value when compared with other columns. Then one statistician has come up with the answer that because ID has numerous levels or categories, that might be causing ID column to have an higher information gain value. Based on this, they started to experiment, and the statisticians view was correct. So consistently, when they had very less number of say levels or say classes in ID column, the particular information gain was coming down. But when they had huge number of records with unique values, with more unique values in ID column, then ID column was coming on the top. So they said that okay, we should somehow remove its effect. So what they did is they divided they divided this information gain concept with the number of levels, categories, classes in each column, and they called it as gain ratio. Okay, so information so what they said is, I will calculate a new ratio called gain ratio, which is information gained by information content. Okay, content is nothing but the number of levels, categories, or classes in each level or in each attribute of the model. That is what information content is. They gave it a new name called gain ratio. So henceforth, all the decision tree algorithms carry the new concept of gain ratio, which is information gain divided by information content. So whichever attribute has the highest say gain ratio value, that attribute will be the root node. This is how the particular number of attributes are divided into and a root node is calculated. So the closest rival to this gain ratio is Gini index. Okay, so Gini index is the other say option if we don't have the gain ratio, but they work on the same process. Now we will learn about pruning. So before that, we will take a small break. It is 8:07. So what I suggest is Take a short break till 8:12 and please come back. After you come back, I will take some questions. Okay. Later we will move forward. So take a break till 8:12 and please come back. Okay, students. Sorry for the delay. I got a call uh, from my office. So let us quickly move back to our presentation. So what we did study is what are decision trees, how to construct a tree, what are rules, how are the rules formed. So rules are formed from the branches. So any decision tree has a root node, a branch and a leaf. So from root node to the leaf is called a branch, which is nothing but a rule. So what are the advantages of decision tree? But what are the drawbacks of decision tree? We didn't study that, we will do in some time. Regression trees. So decision trees can also make up for this regression with a small change. Then how the data is split. So initially it was the entropy concept on which the data was split. Then they modified it to gain ratio, but gain ratio was not gain ratio, information gain. So information gain was suffering from a concept where if a particular column has more number of unique values or say the categories, more number of categories, then that particular column used to get the higher information gain. So higher information gain column or attribute will be the root node. Okay, it's like a leader in the class. So in order to overcome this undue advantage, so what they did is they divided the information gain with information content, which is nothing but the number of uh, say unique categories in each and every attribute, and they named it as gain ratio. So the latest tree algorithm consists of gain ratio. So again there is okay a similar concept like gain ratio, that is Gini index. Then we have something called pruning. So what do we mean by pruning? Pruning is nothing but cutting. If you look at mm, uh, let us say a gardener, for example, if you look at a gardener, what does he do? If a tree overgrows, so he simply cuts the tree to a shape or to a level. So that is called pruning of the tree. Okay, okay, in the say layman's term we call that say gardener is cutting the tree, but in technical terms in decision tree we call it pruning. So pruning means unnecessarily grown part of a decision tree is cut. What is that unnecessarily growing part of a tree? So why should we cut it? So practically pruning is not that important, but it if you do it, the accuracy will increase. So why do we do pruning is when there is an overfitting, means when train accuracy is more than test accuracy, we apply pruning on the decision tree. Once we prune the decision tree, then what happens is that overfitting part is removed, and the decision tree will give a model where the train data is less than the test data. Now, why do we get the overfitting is one main or major concept. So overfitting is achieved mainly during the tree is overgrown. So let me give you one small example. Uh, Let me think it of. Give me a second. Okay. So though this is not a technical say example, but I will try to give that. Okay. Suppose you are riding a two-wheeler which has gears. okay, four gears which are down. So you are used to drive that particular bike with four down gears. Okay, some X type of bike. You are driving it for the last 3 or 4 years, and without looking at the gear itself, you know that in which gear the bike is moving, running. Okay, that familiarity you have achieved. Suddenly, one day, due to some reason, you are given a different bike. Okay, you are supposed to go out and your bike has a flat tire, okay, puncture or something, so you are forced to take another bike. This second bike has a different set of gears. One is down and three are up, or one up, three down, something. Okay, now if you ride the another bike, will you commit mistakes or not? So human tendency is that by going to your usual experience, you will certainly commit some errors, mistake, because your mind is tuned to that old bike type of gears, and at times your mind, okay, thinks that, okay, you are still riding your old bike and you put your gears like you are riding your old bike, but that is totally different. So you commit some errors. So why do you commit? Because your brain has learned too much of your old bike. Okay, it has learned to that extent that it is now thinking that even the new bike is a similar type of old bike. That is what is called too much of learning. When you have your train data and your algorithm or your model learns too much of your train data, till record to record, okay, column to column, each and every value it is learning. But suddenly, if you give a new data which is called test data, which is different when compared to your train data, then models commit a mistake. Okay, so this errors is called your accuracy. So there will be almost zero error while, okay, trying to find out the train accuracy. But when it comes to test accuracy, it might give you some error. So naturally your train accuracy will be more than the test accuracy. So the reason for all this overfitting is one simple concept, that is your model learning too much of trained data. So if you build a bigger tree with each and every record, with each and every column in the record, your algorithm or the model will learn too much of trained data. A small change in the test data will give lower accuracy for the test data, but a higher accuracy for the test data, sorry, train data, and it will overfit. So in order to avoid this concept of overfitting, what we do is, as a data scientist, we will see till which part or till which length your tree is learning. After that, it is error, we will cut it down. So this cutting down of the extra part of a tree is called pruning. Now you can ask me, how can we prune at a particular point? How would we know? So one good thing is, we will try to experiment. Okay, there are two models in decision tree. One is C5.0 and the second one is CART. These are the two sub algorithms which come under the decision tree algorithm. The first one is C5.0. C stands for classification. So classification 5.0 is one type of algorithm. The second one is CART, classification and regression trees. CART is the second subtype of the decision tree. So in C5.0, we have to experiment so that we will remove that overfitting. But C5.0 is a simple algorithm. but a very beautiful, okay, worked, proved algorithm where most of us use C 5.0. But when it comes to overfitting, we have to do some part of the experimentation, trial and error process. But when we go to the cart algorithm, the cart algorithm is a little bit tedious, okay, tricky and difficult algorithm. But the good thing in cart is that if there is an overfitting, we can convert. See, overfitting is nothing but an error. We can convert that error into a tabular format. We can check where, okay, it is coming error, and we can prune over there. So till that part we can keep, and the rest where we find that error is beginning from that part or from that location, we can cut the tree at that location. So in one term, C50 algorithm is simple to build, work and understand. Rules are very straightforward. One problem that occurs with C50 is when it overfits. So little bit of experimentation, trial and error is required. Coming to the second algorithm, that is CART, which is little bit tricky, confusing, tedious to build. But when it is overfitting, the work becomes little bit easy by converting that error or overfitting into a table, and we can prune, we can cut at that location where we find that the error is located. Okay, so this is all about our decision tree algorithm. So now we will deal with C 5.0 algorithm, and when we do a random forest after this, I will show how we can prune it. Okay, so with this our simple learning of, okay, decision tree is done. I will take few seconds of pause, and I will take some questions from your end. So any doubts and all, you can now ask me. I am ready to clarify your doubts. Any doubts, please ask me. I am ready to, okay, answer your doubts. See, you should have some doubts. Unless and until you think and you come up with some doubts, it's very difficult to learn these technical things. Okay, okay. So I assume that you, okay, have fully or totally understood the concept. With that assumption, we are moving forward. So now we will do one thing. We will start our coding. Okay. So how to solve a problem with the help of decision tree algorithm. So the rough process is like this. Let us assume that the data is spread in multiple files, okay, different files. So first thing is we should do some small manipulation in the files where the data is spread. After we correct it, then we merge the data into a single file. Then again we will go through each and every column, each and every row. Wherever we find some processing needs to be done, we will do the processing over there, and we will divide after processing is completed. We will divide the data randomly into train and test. Then we take the train data, we will pass into the algorithm. So here the algorithm is decision tree. We will pass the algorithm into the decision tree. We will build a model. Once the model is built, we will take the train data. We will pass that okay data into the algorithm, not the algorithm, the model. So what we get is train accuracy. So we take this train, what I'm saying, we will get train prediction. Sorry, I'm lost somewhere. I will repeat once again. So once we process the data, we divide the data into train and test, train being the larger portion and test being the smaller portion. So we take the process the train data, we pass into the algorithm. Here the algorithm is decision tree. So what we get as an output is a model. So again, in the next step, we take the same train data without any changes. We pass that into the model. What we get is train predictions. So these train predictions are compared with train actual dependent column. Okay, from the train data, what we get by comparing the train predictions with the train actual dependent column is train accuracy. Then we take the test data, we pass that data into the model, we get train test predictions. These test predictions are compared with test actual dependent column. So by comparing the test predictions with the test actual dependent column, we get test accuracy. So we have train accuracy, we have test accuracy, we compare them, and train accuracy should always be less than the test accuracy. Okay, then we assume that the model is working fine and we will accept the model. In case, in case if train accuracy is more than the test accuracy, that okay case is called an overfitting case. Okay, it means that the model has learned excessive, okay, more of train data and less of test data. So that is the reason it is giving more train accuracy than the test accuracy. So the solution is we will go back to our processing stage. We will have a relook into each and every step we have done in the part of processing. If we think that there should be a change in this, so we will change it, and accordingly we will divide the data, we will build a model, we will find train and test accuracy, and we will compare. So here when compared, train accuracy should be less than test. Till that stage we will go on building the model and comparing. So once we have train accuracy less than test or test more than train, then we will say that the model is fine and we will accept the model. So this is the process we are going to work on with. So the first criteria or the characteristic of a data scientist is he should have patience. Why? Because the same job is done in multiple ways and number of times. It's not like a Java programmer or a .NET programmer where certain specifications are given. You take some time, you achieve it, and your job is done. It is not like that. Okay, you build a model, you compare, your test accuracy is less than train, again you go back, you do it in a different way, and you compare it again. If it is less, you need to go back. So no one knows how many times the same process needs to be repeated, but let me tell you, the process needs to be repeated till that train accuracy is less than test accuracy or test accuracy is more than train accuracy. So for all this, it might take one day, it might take okay a week, or even sometimes it might take 1 month. but at the end you should do it as a data scientist, because client is giving money. Unless and until you do it, you achieve this, client is not going to pay us. So the first criteria is patience, extreme patience. Second criteria is eye for detail. When right from, okay, you attend, suppose you are a part of the team and you are fair enough, you are, okay, say good enough to attend the client meeting where the client is explaining about this company, about the problems he is facing, about the data he is carrying. You should note down each and everything, because there are few clients who will not repeat again and again. If you go to a client meeting after few days, if you get any doubt, you call the client. The first thing he asks you is, okay, what did you do on that day when I was explaining you? So so is this the way you carry on with the project? So that's very embarrassing. So you should always have an eye for detail. Okay. So what I used to do is, initially I used to take a small device with me, recording device. Okay, we used to have a Sony device recorder. With the permission of the client, we used to keep it on the table, and we used to start the project talk, so that even if we miss something we can hear it back. Okay, and it will also act as a proof that client has said this and we have said that, and this is what we have discussed on the day. So client cannot say okay, something which he didn't share with us. At the same time, we can not escape from our duty. So it acts as a say backup. That is what we used to do, but some clients will not agree. Some clients will not agree to keep a recorded ones. Okay, because some things they share might be their company's personal data, so they don't want to put it on record. Second thing, suppose a manager of a client is handling, so he don't want something to reveal in front of others, that is as a project partners, I say outsiders, he may not want to share some details. So these are some issues we might face by keeping a recorder. So the best thing is, and the simple thing is, try to note down the details as and when the client says. Okay, it is the best thing as per my experience. Okay, so with these two small things, we will proceed. Okay, so let me open R for now. So students, now again typing the code and all will take a huge, will eat into our time. So what I do is I coded something. Okay, in the evening I am keeping it ready, so that we can concentrate more the data. Okay, more on the process of the model rather than the code. So as I said, when we start the project, our focus will be more on the algorithm rather than the code. So learning the code till now, what we have achieved is your duty. Okay. So what I do is I will copy the files that are required for us to build the model. Once we are through with the model, we will uh, hold on for a moment. Okay, I have got it. Good. See, sometimes I keep it here and there. So when I go and try to look at that, I don't find it. Okay, it creates some issue for me. Okay. So let me also share the data that we are using for this project. Again, I am saying this process is going to continue for say 3 4 classes. So you should be extremely patient. Second is compulsory, you should attend. If you miss one class, then you may not follow the remaining classes. Okay, so I say don't skip or bunk the classes if you really want to learn. Okay, students, with this small things, we are entering into the beautiful world of programming. So more than you, I am okay passionate. One, no, it's no, I didn't share it. Don't worry. I will be sharing because I am opening still. Because as I said, as I take classes, I keep somewhere here and there, and I am searching now. Don't worry. Okay, Gauri, I will be showing you each and everything. So let us start with the first file. So Gauri, can you see the screen? I have shared one Excel sheet. It's not getting shared. Why? Let me share it once again. No, right? Okay. Uh, Let me share it once again. Okay. What is the problem that I'm facing? It's coming, but it's not sharing. Okay. Not an issue. What I will do is I will copy the data into R and I will share the R screen. Okay. Let us do that because it is taking, I don't know why it is not sharing simple screen. So for now, what I will do is I will copy the R file into the data, that is the Excel sheet into the R file, and I will share the screen for now. So give me a second, students. Okay, students. So hope you are able to see my R screen now. Can someone confirm whether you are seeing my R screen? Yes, very good. So I don't know why Excel sheet I am unable to share. It is showing as sharing, but it is closing down. Okay, not to worry. We will work in R directly. So first, what I will do is I will read each one of the file and I will show you how the data looks. There are 4 files. Okay. So let us start with the first file. Let me check where my current working directory is. So I am in C drive users home documents. So my current working directory is this. So I want to set a new working directory. So let me write here checking my current working directory. So which is different from where my files are stored. So my files are stored in F drive. In that I have something called R analytics course modified folder. In that I have a subfolder with trees. Okay, that is decision trees. In this I have all the files. So now I should set a new working directory. So setting a new working directory. Good. So let me execute. See, please go through that. I will do some coding. I will stop and I will take questions. Okay. So once it is set, the working directory is set. Now go and run get wd again. So and see whether the set working directory and the get working directory output is same. So I find that they are same. So a new working directory is set. Now use dir or list.files function to find all the files that are present in this working directory. So I have around 27 files in this directory. What I mainly look at is data, credit card, data demographics, data loans, and data other accounts. So these are the four files I am interested in. My data is spread in these four files, and these four files are present in the set working directory. So I am fine with it. Or use list.files, you will get the same output. So you can use any of the function, that is dir directory or list.files. Once you are confirmed that all the files which you require are present in the directory that you have set, we are good to go. Now let us understand this code. So the data is in CSV. I use read.table function followed by the name of the table with the extension, because each column has a header name. Okay, we say header is equal to true because it is a CSV file. Separator is equal to comma. Let us say the client has given some other names which I am not happy with. So I am setting my own names. So this particular file has around 8 columns, so I am giving 8 names. Okay students, so 8 columns, I cannot give 5 names. I have to give 8 columns 8 names, else it will give us an error. So so the number of rows is immaterial. Mainly we are concerned with columns. So the first column is id, second is age, third is experience, fourth is income, fifth is zip code. Zip code is like your pin code. Then family size, education, mortgage means whether that individual has some other loan, existing loan. And I call this file univ. The first file I am calling it as univ. Okay, because this is say a bank's data set. I have changed the name to universal bank, so shortcut I am giving as univ. Because I use this n number of times, I am little bit lazy. So the data is copied correctly. Then we will look into the number of dimensions. Okay, dimensions, as you know, gives the number of rows and columns. So we have 5000 records, rows, and 8 columns. Let us look at the head. Okay, so students, this is how my first file looks as. ID has numbers 1 2 3, unique numbers. Age has the age of the bank clients. Okay, so the customers of the bank. So each row represents individual person's data. So the first, okay, individual or applicant has not given his age. So that is the reason it is showing as NA, missing value. Then he has an experience of 1 year. Let us say the income is in $1,000. So $49,000 is his yearly income. He lives in a place where the zip code or pin code is this. The family size of the loan applicant is 4. So he is educated. One means say degree holder. So he is a degree holder, and mortgage is 0 means he has no other loans. Say 155 says $1,55,000. So this is how the data is spread. The data is neatly arranged. Okay, we have 5,000 records and 8 columns, and some cell values are missing. Okay, so let us see. So let us count the number of cells. We have 5,000 records and 8 cells. So 5,000 multiplied by 8 is 40,000 cells we have. So let us count the number of missing values or missing cells. So how do you use it? Sum of each dot NA of univ. Univ is the name of the data set. So 2014 out of 40,000 cells, 2014 cells are having missing values. Means NA values are present in 2014 cells. So 2014 divided by 100, sorry, 2014 divided by total number of cells 40,000 multiplied by 100, it gives around 5.02 or something, 5.001 or something. So out of the total number of cells, 5, okay, 0.05% cells, that is 5, okay, they are missing. So anything which is less than 10 can be imputed. So 10% less than that cells, if they are having missing values, it can be imputed. If a particular column has more than 10% cells which are missing, cannot be imputed. Okay, sometimes you can also impute, but less than 10 is normally imputed. So we have 5, the value is okay, fine, we can impute them later. Then as I said, structure function, let me also run class function because I want to know in which data structure univ is stored in. It is a pure data frame which we always like. So in place of running all this, you can run a simple structure function. It gives the type of data structure, number of rows, number of columns, names of each rows, data type of each rows, and the first 10 values. Okay. So you can also execute summary function. Okay. So it is taking some time, not to worry. So because we have all numeric columns, integer or numeric, for each and every column we will get the minimum value, max value, mean, median value, first and third quartile value, and the missing cells in each and every row. Okay, so 273 divided by 5,000 into 100, it is less than 2.5% or nearly close to that. So the missing values can be easily filled. Similar to that, we have something called experience, income, and all. If you look at all the columns which are having the missing value number, it is less than 10. So we can simply go with it. Okay, we can impute the values, means we can refill the values. So structure and summary functions are easy to work. Okay, or if you want to look at a particular column and find the number of missing values in the column, we can write this simple function, that is sum of is.na, the name of the data set, dollar, the name of the column. So if you execute, what we get is 273 cells in age column are missing. The same if you look at the summary function under age, you have NS data, it is 273. So they are matching. So you can check both ways, but I prefer summary. So structure and summary are the most important functions you should execute. Got it? So what we want to take a book, take a pen. Okay, simply keeping in mind will not do. You should, as a data scientist, you should write down. So write it down. Table one name is actual name is data demographics. In R it is univ. The data is neatly spread except it is having some missing values. You also note down the number of rows and columns. Okay. Then let us look at the second table, which I am calling it as loan calls. We have only three columns, that is ID, info, rec, means let us say the bank has called the individual applicant to know some more details. So how did they contacted the applicant? Through email or phone. So a phone is not visible, but I know that it has only two categories, that is email or phone. If it is through email, they have written as email. If it is phone, they have written as phone, PH. And loan, whether that individual was given a loan or not. 0 represents the loan is not given. 1 represents the loan is given. Okay, let us also look at the number of rows and columns. We have 5000 records and 3 columns. So the first table has 5000 records and 3 and 8 columns. Second table has 5000 records and 3 columns. So the number of columns are different, but number of rows are same, which is a good news. Let us also look at the missing values. There are no value, NA values. So 5000 into 3, we have 1500 cells and all the cells are having values. There are no NA values. This is another good sign. Let us look at the structure. So it is again in data frame, and inforec is a character type of column. The remaining two are stored as integers. Okay. Let us quickly look at the third and fourth tables, and we will stop here. In the coming class, we will proceed further. So credit card data, I am storing it as CC because I don't want to put bigger names, because I say often use within the coding, so it will eat my time. So I keep it in a short. So we have ID, the month in which the loan was given, and the monthly installment or something. Okay, how much they are supposed to pay. So monthly, okay, it is credit card, right? So month January, that individual has paid this much of credit card bill. Second individual in the month of January has paid this much of credit card bill. Okay, let us also look at the dimensions. We have 60,000 records and 3 columns. See, the first table has 5,000 records, 8 columns. Second table has 5,000 records and 3 columns. Third table has 60,000 records and 3 columns, which is very huge. Okay, where is 5,000, where is 60,000? There is a huge difference. Here comes our first difficulty. Okay, so we have around 180 cells. Out of that, 1768 are not there, missing, which is a very minute number that we can fill it up. But the problem is there is a huge difference between the first two table rows and the third table rows, number of rows. So we will see in the coming class how to handle. Let us read even the fourth table. Okay, let us look at the number of rows and columns. Again, 20,000 rows and 3 columns. So third and fourth tables are a little bit difficult to handle. So we have ID column, variable. Let us say variable means the bank has savings account, the bank has fixed deposit account, let us say some share trading account, so on so forth. So securities is one type of account. Whether that individual has that account in the branch or not is one. If he doesn't have that account, it is zero. Okay, so let us look at the structure. Again, we have three columns, right? Two columns are integers and one is character. So first two tables are neatly arranged except missing value in the first table. Second table is neatly arranged with no NA values. They are good to go. Third table 60,000 records and three columns. Columns are fine, but number of records is very difficult. We cannot straight away merge them. Third table is that fourth table has 20,000 records. Again, when compared to 5,000 records, it is almost four times, which is difficult to merge. Again, we need to apply some manipulation techniques. Okay, so the first thing is we should look at third and fourth table, do some manipulations to bring the number of rows to 5,000. See, it is not a wise advice to bring 5,000 records to 20,000 records. It is not a wise advice. It is always good that the bigger table, the table with more number of rows should be cut down, and we should bring it to the lower number of records because processing becomes easy. Okay, because we have exceeded the time. So keep a track of this in the coming class. I hope tomorrow we have a class. Again, we will start afresh. Okay. I will recap and we will go through how we can manipulate this data. Once we manipulate, then only we will merge the data. Okay. So any doubts in this? So even if you have doubts, we can clarify it tomorrow. In the first 10 minutes, I will take your queries, your doubts, and I will try to solve them. Once we are good to go, then we will start with our actual project. So don't, okay, take a break. So with this, I am leaving. We will meet tomorrow at 7 p.m. Okay.